lecture program in the memory of their beloved ex-faculty members, and which includes some technical lecture programs also. So a couple of joint meetings between the GAABESU and Electrical Engineering Department faculty members were held. From there, the very apt name, that is Legends and Legacies lecture series, was conceptualized. I feel this is the most apt term to pay the respect and gratitude to the seniors by the juniors, be it be between the current and ex-faculty members, or it be between the alumni and the current students of the department. So I really feel very proud to be here as the welcoming speaker of this program. Now about Professor Sen. Professor Sen was admitted in the Department of Electrical Engineering in the year 1944, and he was graduated in the year 1948. After that, in the year 1950, he was also associated with the department as a research fellow Government of India and was there in the department up to 1952. Leaving the department for some time, he again joined in the year 1956 as the faculty members. His tenure in the department as HOD was from 1965 to 77 and 81 to 86. In the year 86, he quitted the department for that time and he joined Jadavpur University as the then Vice Chancellor. He also has won the state assembly election in the year 1991 and 1996 and was made the power minister of the state for about 8 years. It is really a very important point to note that with his initiative, he has made our state as a power surplus state. Before that, the stakeholders were really suffering from the extensive load shedding in our childhood time. So it's a big contribution by Professor Sen to all the inhabitants of the state of West Bengal. So with these few words, it is my utmost belief that the legacy of such a legendary figure should remain in the hearts and minds of his colleagues, students, and whoever he has interacted with for a long time. So I should not extend my words very much. So I should wrap up with these few words that we should continue to maintain the legacy he has set to the minds of the associated personnel with this department and in a larger sense to this institute, so that we can do justice to our respect and do respect the eminent personalities of this great seat of learning. So let me wrap up again with a big thanks to all of you. So we are very eager to hear for many of the dignitaries today. So at the end, I should give a big thanks, and we should hear the rest of the dignitaries from now.
Thank you, Madam, for such a great introduction. Now, I would like to request President GAABESU, Anirban Roy, to say a few words about the program. Aurobindra Roy, to say a few words. Sir, please.
Good afternoon to everybody. On behalf of GAABESU, I welcome Professor Devashish Dutta, International Relations and Alumni Affairs, respected Professor A.M. Ghosh, Mrs. Sumita Dutta, Chief General Manager, DBC, other respected professors, alumni, and dignitaries present here, my colleagues and beloved students. To first memorial lecture of Legends and Legacies in Electrical Engineering Department of this institution. In memory of Professor Sankar Kumar Sen, and most of the things has already been described by the present head. So in our time, when I was a student, there was a galaxy of teachers here. And Professor Sankar Sen was an excellent teacher, apart from other so many jobs he has done. So now, Professor A.M. Ghosh or other teachers may say something about the who worked with Professor Sen. They may describe certain other things, but with this Legacy and Legends series, there may be other departments too will continue with this type of lecture. And with these few words, I am concluding my speech, and thank you again. Okay, and I hope you will enjoy this memorial lecture. Okay, thank you.
Thank you, sir, for enlightening us with your valuable talk. Now, I would like to request our Dean IRA to speak a few words.
Respected Professor Anandamohan Ghosh, Head of the Department of Electrical Engineering, Professor Anindita Sengupta, our guest speaker, Ms. Sumita Dutta, who is the Chief General Manager of DVC, my beloved Aurobindo Da, because we have taught together, my ex-colleague of GAABESU, Secretary GAABESU, members of GAABESU, my colleagues, present day colleagues and ex-colleagues, because I am here in this institute for the last 35 years. So I have taught almost with everybody present here. A very good afternoon to all of you. First of all, I would like to thank the GAABESU and Electrical Engineering Department of this institute jointly for conceiving this lecture series, Legends and Legacies, and in the memory of none other than Professor Sen. Because if it is to be from electrical engineering, then the first name that comes to our mind is one and only Professor Sankar Sen. I am unfortunate in one way that when I joined here in 1988, October, by that time Professor Sen has retired. So I did not have a chance to talk to him personally. I saw him once or twice when he came to our institute, but it is my misfortune, I consider. If one starts talking about Professor Sen and his achievements, it will be an endless thing, 2-3 hours will fly away just like that. So I will not try to make an attempt to do so. Rather, I would try to highlight some of the salient points that is there in his career or character or personality in various forms. I am very much thankful to Professor Gautam Bandyopadhyay, who has given me a lot of knowledge over telephone regarding this. First of all, Professor Sen is a brilliant student. He is a gold medalist from 1944 to 1948. And you can understand this. When he joined as a faculty in 1956, 1956 he joined this. Before that, as our head of the Department of Electrical Engineering said, he was here first as some research fellow, and subsequently he went to Imperial College London to pursue his PhD under a great professor, Professor Atkins. That must been a great work, although I don't know about it. And after that, he came back. Just imagine the sacrifice and selflessness of this person for his country, that he went abroad, did excellent job, a brilliant person, he could have stayed there. And he could have excelled there also very well. But he did not care for that. He came back to his motherland to serve his country. And not to any other institute. He never switched to any other IITs or IISCs, which he could have done very easily, but stayed back in his alma mater. That's a great thing. We should all learn and cherish our. Professor Sen was a brilliant student, a brilliant teacher, a brilliant academic administrator, and also a general administrator. In all these, he had excelled like anything. So I am extremely thankful to the GAABESU and Electrical Engineering Department for organizing this memorial lecture in the name of Professor Sankar Sen first. That should be the first lecture. At the later life, after retirement, Professor Sen became Vice Chancellor of Jadavpur University, another seat of great seat of learning, and also became subsequently the Power Minister of the state. And what he did in this capacity, that is also known to all of us. At the same time, he did not compromise anything. And that's why in his second term, he left it. He did not care for the position or for the chair. He had an altercation, and the man of principle that he left the post immediately. One contribution of Professor Sen I would like to highlight before concluding, that is, this institute has seen many conversions. We were a government engineering college, we became a deemed university, we became a university, then now we are in IIST Shibpur. I consider personally, out of all these transformations, the most major and important transformation was that from the college to a deemed university. Because there we got true academic economy. And you will know that semester system was introduced after the conversion of that. We got freed from the Calcutta University. We became academically on our own. We introduced semester systems, and a lot of academic improvements followed that. During the transformation, there was a lot of debates and other things that usually happen during any kind of conversion. During that conversion also it happened. And I remember one meeting with the then principal, Professor Bimal Sen. He came to our institute, he came to our department, mechanical department, and many senior colleagues were asking him that what will happen to us, what will happen to our retirement benefits. Everybody was a bit doubtful. So Professor Bimal Sen only said one sentence or two sentences, that he said 3 persons want this. One is Professor Sankar Sen. He wants this institute to be a deemed university. Second one is Ashok Chatterjee, the then Higher Education Secretary. And number 3, the Chief Minister, Jyoti Basu. So these 3 persons want, and if you believe, if you have any faith in them, then don't worry, you will not be diverted from anything. All the benefits and other things will be taken care of. And that exactly happened. Yes, it took some time, but it did happen. But the benefit was tremendous. This was the vision of this person, Professor Sankar Sen. A great administrator, a great visionary, in not only in electrical engineering, but also in every arena. So I will not spare much time, but I am also thankful to the speaker who has, in spite of her busy schedule, she has agreed to come over here and deliver a lecture. It might be a very interesting topic. I don't know much about this. So you all enjoy this, all electrical personalities, for this lecture. Okay, thank you very much.
Thank you, sir, for your insightful talk. Now, it's my immense pleasure to call Professor Ananda Mohan Ghosh to enlighten us by saying a few words about Professor Sankar Kumar Sen.
That's all. Hello. Respected dignitaries sitting on the dais, my ex-colleagues and students present in the audience. I am not a product of this B college. That means I was a student of, I did my BTech and MTech from University College of Science and Technology, Calcutta University. Then had some industrial experience there and joined B college in the year 1968 as the lowermost lecturer of the Department of Electrical Engineering, where Professor S.K. Sen was the head. I met Professor Sen for the first time in the interview board of the Public Service Commission, Government of West Bengal. His very outlook was so bright that anybody unknown to him will be astonished with the brightness that radiates out from his mouth, from his face. I was also impressed. And I thought that if I get a chance to work under him, I will definitely be very much happy and I will be fortunate enough. I was selected, means that interview took place in 1967, and I joined B College in the month of January 1968. I reported to the head of the department, Professor S.K. Sen, and I told him that what should I do now? He said a very, very interesting thing. He said, you did your MTech in 1963 and you were in the industry for 4 years. By this time, you have forgotten all academic things. So you have to study now as a student. But being a teacher, how can I act as a student? Okay. He made a very simple, he gave a very simple solution. He said, attend ME, means postgraduate classes of the senior most teachers, and see that how we give lectures to the students, acquire from them. It's very fine. I did it. And not only that, it said that since you were not a student of BE college, you have got no idea about the laboratories that we are having and the way we do our laboratories and the facilities that we offer to the students. So you must know that first. So go to the laboratory, every laboratory, perform each experiment yourself. And then you will be able to teach them properly, conduct laboratory classes. And so there will be no teaching class now for you. As a student, so teacher come student, you will, that is your task, you do it. I will giving you 6 months time. And after 6 months, he gave me lecture classes and laboratory work and started doing it. But I said, so that I want to do PhD work under your guidance. He said, all right, go to the library, go through the literatures, technical journals, and select some problem of your choice. And then come and discuss. I'm telling this thing specially to say that how he applied some methodology of his own, and he wanted to groom me and making me most suitable for the department which is new to me, or rather to the institution which is totally new to me. Okay, whenever I faced any trouble, I used to go to him, and he used to give very simple solutions. And solutions means not direct answer to the questions, but the study materials and references where from we can get the answer. That was his technique for grooming a teacher. By that way, I started, he allowed me to register for PhD program after 2 years, when he felt that he is now okay and he will be able to conduct PhD work. I joined B College in 1968. In 70, I registered myself for the PhD program, and I completed that in 1974. Means degree was awarded by 1970. So he was my guide, and he was very pleased with my work. And then he said that you should now go to some foreign universities and do postgraduate work there. Postdoctoral research work there. Do some postdoctoral research work. He suggested that you go to Imperial College London. He also did his PhD from the Imperial College London. So he was very fond of that. And he made the recommendation and sent the proposal that I want to send one teacher, and please allow him to conduct the postdoctoral work. They said that all right, we will allow the person that you have referred, but he should send us a scheme and proposal of his postdoctoral work, that what is going to do. Naturally, a proposal was made, and that in that proposal, it was given, because under the guidance of Professor Sen, I did some research on power system improvement by controlling excitations of the generators, synchronous generators. And at that time, digital technology was not known. That is, computer was not there, digital techniques were not there. Only a little bit of NOR gates operations were possible at that time. And my scheme is that we must develop some digital devices which can be attached with any machines and systems, so that that machines and systems can operate as an intelligent machine, means can behave as a self-controlled machines without any need of operator, and also the performance of the machines will be most efficient. Okay. They accepted the proposal and gave the consent letter, sent the consent letter. But I could not go because at that time, my mother was alone and there was none to look after. And naturally, my mother said that you cannot go. Professor Sen was very much depressed, noting that it's not possible for me to go there for that research work. Then he gave a solution immediately. That the proposal that you sent to them, can we not develop the facility here itself in this institution and develop a digital laboratory? And that clicked. That is, his idea was that he can convert any disadvantage into an advantage. That was his very unique technique. And Imperial College actually gave a suggestion that the idea that was proposed, that machine performance can be improved by using digital techniques. They said a new such device called a microprocessor has come to exist. You can have it from USA. So he said, okay, we'll develop a microprocessor laboratory and we'll import these microprocessor chips. And you are to develop that yourself. And that will be your postdoctoral work. I am telling you this thing in details because kind of, I should say, farsightedness, what kind of zeal, what kind of dedication, and what kind of guidance that a man can give, that I realized. And I am really fortunate that I worked under him. And whatever I have done for this institution, it has been possible for him only. Now, I don't want to take much time because there are many more speakers. Quickly, I will run over through the details of my career here at B College. In 1974, after my PhD, we could import these microprocessor chips and develop the microprocessor laboratory. But who will provide the fund? College said that we will not provide you any fund. Government said, no, we will not provide you any fund. Then Professor Sen told me that you send a proposal to the government of India itself that please fund this, because if you can do this, then India will be able to develop a new technology. That means design of digital-based machines and systems. We were very lucky enough that government of India provided the fund and the microprocessor laboratory was set up. I think I have seen that my same microprocessor laboratory is still existing. It is existing. Okay. So microprocessor laboratory was ready. Government of India had one condition, that whatever software and hardware that you will develop will be the property of Government of India. You cannot disclose it to anybody. You cannot publish any of your materials. So everything you have to hand it over to the Government of India. We did it. We had to do it. We recruited. They said that we will provide you 2 research scholars and 2 technical assistants to develop that laboratory. After every 6 months, a team from the Department of Electronics used to come and visit us to see the progress. They were very happy with the progress. The software and materials that were developed by the laboratory were taken by them, and they used it, that the Department of Electronics, Government of India used it for their own purpose. And sometimes we had heard that they exported that technology also to some foreign countries. At the final inspection, after 2 years, the government team that came from Delhi said that we have decided now to choose 7 engineering colleges where computer science departments will be started. They said these 7 institutions are, at that time there were only 5 IITs, and the 6th one is Jadavpur University, and the 7th one is BE College. IITs were IITs, it was central government's child, and Jadavpur University was a university. BE College was a government college then, under the control of the government of West Bengal. They said, no. We cannot allow BE College to start computer science department because computer will kill employments and will not generate any new employment. So that was the output, because at that time CPM government was there, and they did not allow to start computer science department at BE College. Professor Sen said, no. This we cannot agree with them. So they must be convinced somehow. He took me to the Chief Minister, Mr. GAABESU at that time. He himself said that I have brought my colleague. He will tell you that computer is not a job killer, but computer is a job creator. He said, convince me. So I said that it will create jobs, because the technology, if we can develop quickly, proper technology we can develop, that all our maintenance productivity will increase, new industries will come, new techniques will come, and their people will be required. And computer has got 2 parts, the software and the hardware part. Not only the hardware industries will grow, but the software industries will grow. At that time, it was unbelievable to say that whatever presently what you find, that the jobs are mostly computer-oriented jobs. So far as engineers are concerned, jobs are mostly computer-oriented jobs. And they are getting high salaries, and they are going mostly to the foreign countries, because demand for the computer science engineers are very much there in advanced countries. Okay, I will not take much time. I am telling you these things because this is what is Professor S.K. Sen. The computer science department was started here in the year 1982. And Professor Sen became the first professor in charge of that department. Because government order is not there to give appointment to any teachers, to professors and lecturers. So there was no government order. West Bengal government took about 2 years to give the order, and ultimately the department started functioning. And when that government order came, I joined the computer science department in the year 1984, where at that time, the computer science students were just admitted to the third year level, means went up to the third year level. Professor Sen left B College because he got he was offered the vice chancellorship chair of the Jadavpur University in the year, what I remember is about 87, 86, in the year 1986. He went there. So I was guardianless from that day. However, I could run the department and retired from that department in 2001. I am telling you this thing, the contact with Professor Sen continued till his death. He used to take me as his younger brother. Even family problems, engineering problems, state problems, whatever may be there, he used to talk to me as if he was my friend. I consider him as my friend, philosopher, a lifelong guide, a lifelong friend, philosopher, and guide. I have never seen a person, such a person like him. A teacher can be, he was father-like, he was friend-like, he was guide-like, but he never used to tolerate anything undesirable, anything wrong doing, anything this. So I was fortunate enough to have his blessings, and I feel proud of that I could satisfy the demands of Professor Sankar Sen. I pay my great homage to him, and I will remember him till my last day. Thank you for the present.
Thank you very much, sir, for sharing your interactions and in different aspects you have made with Professor Sen. And we would also like to express our immense gratitude to you for whatever you have done in betterment of this institute. Thank you, sir. Thank you very much. Now, I would like to request Secretary GAABESU to provide a small token of gratitude to Professor AMG, sir. Now I would like Professor Anand Mohan Ghosh sir to felicitate our respected speaker, madam. Madam, please come. Now I would like to request our Secretary GAABESU to give a small token of memento to our respected speaker, madam. Madam, please. Now we are going to start our main program. I am sure that we all will feel enriched with knowledge after completion of this event. Now, I would request our Secretary GAABESU to introduce our honorable speaker, Ms. Sumita Dutta Nag, Madam.
Good afternoon to you all. To my teacher, Professor Anand Ghosh, Professor Alok Das, Dean IIRA, Professor Devashish Dutta, HOD of Electrical, Professor Anindita Sengupta, my other professors, senior and junior alumni and students. This has really become a high voltage gathering, so non-electricals should little bit be beware. It's a privilege for me to introduce Ms. Sumita Dutta Nag, Chief General Manager of DVC, for this first lecture of Legend and Legacies series in the memory of our teacher and alumni of this institute, ex-professor and HOD of Electrical Department of BEC, ex-Vice Chancellor of Jadavpur and ex-Power Minister of Government of West Bengal, Professor Dr. Sankar Kumar Sen. Actually, when I proposed her name for this lecture, I requested Madam HOD Electrical to assign this job to me, and she very kindly obliged. Sumita is my classmate, so I took this chance of talking about her. Sumita Dutta at that time, she passed out of Bengal Engineering College from this electrical department in 1987. And she is one with whom I have regular contact all through this last 41 years, even before this mobile and email came into picture. She started her career in a microprocessor-based firm for a short term and then shifted to DVC in May 1988. Initially, she was in Central Testing Laboratory of DVC in Maitan, where she used to handle system studies, fault evaluations, protection of entire DVC systems. For more than 2 decades, she was involved in DVC modernization of power systems, including substations and power system protections. She has participated in various substation projects, starting from conceptual stage up to commissioning. She has also contributed to various technical journals, including CBIP. In later stage, she has also worked in various managerial capacities in various DVC departments, including HR, commercial, corporate planning, and secretariat. However, for me, the most important thing is that as a woman professional, she has managed over so many years, not only her professional work front, but also her family commitments, raising a child without withstanding the social pressure of a working technical professional in today's social environment. Incidentally, her family, immediate family, also includes 4 more BC alumni: her husband, her son, daughter-in-law, and his brother-in-law. So I welcome Sumita to come over here and give the lecture.
Thank you.
PowerPoint দিয়ে মানে আমাদের জুম দিয়ে দেখাতে চান নাকি এমনি জুম দিয়ে দেখাতে কোথায়
Respected Professor AMG sir, respected other seniors in B College, respected Madam HOD of Electrical Engineering Department, IIEST, sorry, and GAABESU office bearers present here, and my dear students. So, I cannot express my feeling today. First I was, when I was listening to thank you. When I was listening to the previous speakers, especially Professor AMG sir, so I thought maybe God is there. So I have been present in this today's program in this institute, my alma mater. But when I was introduced, I was not feeling so well. And I was wishing the Dr. AMG continues for a longer time. It was really a good time to hear about the stories of Dr. Sen and Professor AMG. My deepest gratitude and most humble regards in memory of respected Dr. S.K. Sen. It is my great honor and privilege today, one of my greatest day and gifted day today, it seems, that I am present here while all of us are paying tribute to none other than our revered Dr. S.K. Sen, the name we utter with absolute sense of pride to be associated with and to be blessed by. It's truly special to be able to honor and reflect on the contributions of someone who has always been perceived as the epitome of knowledge, discipline, and dedication to the society, whom we had the privilege of experiencing so closely and are humbled to be inspired by such a great persona. He was in fact a phenomenon by himself, starting from his style and quality of teaching. to his entire role as our guardian for the 3 years when Dr. Sen had been our head of the department, electrical engineering. There is no doubt that Dr. Sen had a profound impact on most of our contemporaries who are pursuing different fields of electrical engineering as their career. So I could not avoid saying these few words about the today's first SK Sen Memorial Lecture. Coming to today's topic, I am not a speaker at all, actually. I am an ardent worker, you can say, but and I'm associated with the industry, power industry for a very long time, more than 35 years. But the technical experience is now past for me. Now, as I am handling only administrative jobs for several years. But still, I would, as I have come here, as I have been invited, and I have been so much honored today, I cannot forget this day throughout my life. So I will try to some words for the students especially. About my, a little bit about my experience, because recently I was not so well, so preparation is not my best, okay? My topic today is overview of design of a grid substation. It's nothing, not a very contemporary topic, but as we all know, that electricity is the one thing that human civilization asks for if one thing we need for civilization, so electricity. So, and the demand as a growing nation, our demand is only increasing, at least in India. So there is a huge growth of demand now. And in spite of having the renewable and non-renewable things, for some years, the non-renewable will continue in India at least, becoming coal-rich and other factors, especially the base load throughout the day we have to maintain. So we have, but as electrical engineers, we have as a core electrical engineers, we have the duty to do more to improve the grid, actually. So by grid, we mean what is an interconnection between several components or several networks of the power system. So it can be a local grid to which the generating stations are connected, transmission lines are connected, and the substations are also connected. So the several substations will be there. It may be levels, but today we are discussing only a 220 or 132 kV grid substation. So what is the role of the substations? Substations constitute of transmission system which interconnects the transmission circuits, transformation between networks of voltages, and they play the crucial role of maintaining the stability of the grid. So the generated power reaches from through the transmission system to the end user. Here, I consider the 33 kV, just as in DVC, as my experience is, 33 kV, major consumers are at 33 kV for DVC, and we are supplying power through these substations. Earlier, DVC is actually pioneer in making this transmission system in Eastern region. Earlier, our 132 kV grid was the ring main grid, as the generating stations were all at 132 kV. Then came the 220 kV generators, and the 220 kV grid came into being. So finally, now the 400 kV grid is also there, but our the takers of power, the industries, they take mostly from 220 kV by 33 kV or 132 by 33 kV substations. Okay. So substations form the nodal point of incoming and outgoing lines. It transforms the voltage, but its main role is to maintain the stability, because all the automation and control, it is there. So whenever the electrical system, as it is prone to threat of faults, so it is only at the substation that that control of isolating the faulty part that is on the substation. So it is the heart of the transmission, I mean grid. So before coming into the concept of making a new substation, we have to study the system, look at the generation load characteristics, how much is the fault MVA we have to know, but whether we have a surplus generation to supply to the new consumers, and whether the transmission line that is having the capacity to carry the additional power. Successful operation of entire power system depends to a considerable extent on efficient and satisfactory performance of substations. It comprises of power transformer, switch gear, control, protection, monitoring, and automation equipment. So it is required to pay careful attention in planning, designing, and constructing substations, since its reliability directly affects power supply availability. So here we will consider a EHV MV substation, that is 220 by 132 and 33 kV voltage levels it will be having. So what are the criteria before starting our work? A developing load center has to be there in the nearby adjoining area. Availability of excess power has to be there, as discussed already. Capacity of the transmission lines and proximity to the grid. So grid, the lines has to pass through a nearby area where my land is for the substation. It has been assigned. We have to connect the existing grid. So the connection to the substation from the available lines, that has to be first looked at, and also the line corridor and right of way for taking out the feeders. These are the physical challenges we face before doing a substation. A lot of time we do not get permission from the concerned government regarding land and regarding the building a substation. So the challenges are always there for the industry. Now, what are the technical steps? We have to know the fault level by doing a system study. Accordingly, we will choose the equipment ratings. So to have the, for foundation requirement bearing capacity of the soil, that we have to look at. And connectivity, whether we should connect to 220 kV grid or we should connect to 132 kV grid. All these factors we have to take into consideration. To fix the maximum size of the substation according to the land we have got and the number of bays, future requirement, technical, the demand of the industries in future, that we have to always consider, not only the present requirement, we have to look at the future requirement as well. Selection of switching scheme, busbar scheme. So at this level, I'm talking about, we normally have double main bus 1 and 2, and the transfer bus scheme to have the operational flexibility and system safety, reliability, and availability. At 132 kV, we can do with 1 main and 1 transfer bus. A well-planned control room building is most essential to have the all operational control from there. So first we can accordingly prepare the single line diagram. Fine. So I just wanted to show the students a sample single line diagram. Shibpur? Anyone? No. না এটা একটা একটা করে আসবে তো ঠিক আছে so after drawing up a preliminary single line diagram before going for tendering activities, we prepared the bill of quantities to have an idea, to give the tenderer an idea about the requirements for the substation. The bus bars, circuit breakers, isolators, instrument transformers, lightning arresters, wave trap, support structure, hardware connector, insulator strings, etc. Now we have to look at the key factors for safety, reliability, and efficiency to be ensured. So proper layout of the bus, bay, and equipment. So diagram will not come in. The link will not work, no? Okay. Documents are there. But Microsoft Edge করেছিলাম তো ওই জন্য হচ্ছে না আপনি কি নরমালি দেখাচ্ছেন ফোল্ডারে আছে ফোল্ডার থেকে দেখানো যায় তাহলে আমি ওটা আলাদা ফাইলে আছে ঠিক আছে হ্যাঁ হ্যাঁ কি করে করলে So as you can see here, the main bus 1 and main bus 2 of 220 kV, this is a Dhanbad substation taken up in 2003, 2005-06. So we had used the line side cities and 2 main and 1 transfer bus. So there are 2 power transformers, 220 by 33 kV power transformers, and 1 provision for 1 future transformer as well, and 2 auto transformers, 220 by 132 kV, 150 MVA, and some 132 kV feeders and 33 kV feeders. 33 kV is also having the 1 main and 1 transfer bus scheme. So after finalizing the layout, we have to maintain minimum ground clearance and sectional clearances for safety and the electrical operation. So proper technical specification of equipment now comes. I just brought some equipment specification as well, but they're all in separate files. Sorry, I cannot show them. So system earthing through transformer neutral. This is most vital part of the substation. All the EHV systems earlier in the primitive stage, it was they were not grounded. But for maintaining the system, we need to ground the neutral of the transformers so that we can allow the earthfall current and avoid the voltage rise in the system. ঠিক আছে, thank you. No, none of the links are working, sorry. So insulation coordination, then we have to look at, which allows the maintaining the devices so that we can have an optimization, how much insulation we should provide in an equipment like transformer, and how to avoid their damage when a lightning strike happens or some switching over voltage happens. So that is taken care by insulation coordination, how much insulation we will provide at the entry of the line. So we control that through by using surge arresters basically, which is placed very near to the transformer terminal. That way we can protect the transformer without having a very high price of the transformer, because we cannot take care of the over voltage in the system due to lightning or switching over voltage by increasing the normal insulation to a great extent. So that is a challenge. So now there are many standards available following those IEEE, IEST standards and the Indian standards also. We can consult them and choose our system, basic insulation level and the surge insulation level, switching insulation level. So because these wave fronts are a different type, even if a fault occurs on the transmission line that travels into the substation, and that may damage unless we provide this insulation coordination and lightning protection. So surge arresters are normally used for this purpose, and for direct lightning strokes, we use the lightning mast in the substation. Any direct lightning stroke, if it happens in the substation, that is taken care by the use of lightning mast. I'm sorry, the diagrams I took so many with me, but I cannot show them. I can send you later if you want. So protection against electrical and earthing. Earthing is also a major thing in the earthing mat is designed meticulously based on the first we have to see how much is the fault current and duration of the fault current. So accordingly, we have the soil resistivity test of the soil, and then using the available softwares, we design the earthing mat. So it should be very, it is normally made by having the rods connected with each other in a crisscross manner. I mean, a mat is formed using the MS rods of proper size, and the maximum voltage occurs at the peripheral area of the mat. So there the concentration of the rod is made higher to avoid any undesired happening. Safety of the personnel operating in the substation, that is the main concern here. And all the non-conducting parts are connected to the current carrying parts are connected to this earth mat for safety of the personnel. Protection against electrical faults through fastest clearing and auto reclose. So this is the major duty of the substation. So current transformers and potential transformers are chosen accordingly to cover all the fault conditions, and the protective relays are used for clearing the fault. Automation control and SCADA. These are must now for today's substation. We are using the intelligent electronic devices. What was previously known as relays, electromechanical, and then static, then numerical. Now we are using IEDs, and they are all connected to the automation system. So the mimic diagram that we used to see in the control panel previously, those are also gone now. In 220 kV panels, we are using all the control from such a console and the workstation. From there only we are controlling all the isolator operation, breaker operation, even tap changer control, everything has come to the console. Adequate illumination of the switchyard must be provided in a substation to take care of maintenance work. Proper design of cable trenches, separate trench for LT and HT cable should be provided. Proper choice of battery bank. Sorry. So here is a sample of the grounding mat.
Students, please stay for say, 20 more minutes to hear from Madam, because some technical glitches are there still. Madam is continuing, so please take this opportunity to enrich your knowledge and be here. That will not make a huge harm in your today's schedule. So please be here accompanied with your friends and peers so that this lecture will really help you. Please.
PPT টা একটু দিন তো। আসলে আমি জুমে কাজ করিনি তো আগে।
না জুমটা নেই আর।
ও
আর এটা কোনটা চলছে? এটা
এটাতে তো স্পেসিফিকেশন গুলো ছিল, কিন্তু লিংক গুলো তো কাজ করছে না। এটা দেখবো? না তো ইয়েতে যেতে হবে। না করবে না। আসছে না। এজ তো আছে, কি বলছে আমি ঠিক বুঝতে পারছি না। লিঙ্কটা না কি করে দিন, আরেকবার করে দিন। এটা না পেছনেরটা কি করে যাব? এটা না পেছনেরটা কি করে যাব? না এখানে একটা আছে ডিজাইন অফ গ্রাউন্ডিং ম্যাট। ডিজাইন অফ গ্রাউন্ডিং ম্যাটটা কোথায় গেল? So this is the basic parameters chosen for this Dhanbad substation. Nominal system voltage for 220 kV, the highest system voltage should be 245 kV, and the basic insulation level chosen is 950 kV for transformer, and for other equipment it is 150 kV. Power factor withstand voltage for transformer, that is 395 kV, and creepage distance 6125 millimeter. And maximum fault current level is 40 kiloampere for 1 second. So these are the technical parameters chosen for this substation. Minimum clearance to be considered, that is for 220 kV, ground clearance is 2440, that is same for all. And the sectional clearance is which is required for the working of the maintenance staff, that is we keep 5,000 meter, although as per CA guideline, they are a bit lesser. But what we maintain in our substation is 220 kV level is 5,000 mm sectional clearance, and 132 kV it is 4,000 mm, and 33 kV 3,000 mm. So the safety is of paramount importance here at every stage, and the system operation, of course, which is taken care by the protection selectivity of the protection system. It should be sensitive, it should be selective, and it should be reliable. So now we are clearing the fault in around 100 milliseconds, that is 5 to 6 cycles maximum, using the numerical relays. And one more thing I wanted to show. The ArtMat design, some summary sheet I kept here for showing to the listeners. Here also we designed the mat for single line to ground fault current, 40 kiloampere for 1 second. Soil resistivity was found to be 40 ohm per meter at upper layer, and bottom layer 10.45 ohm meter. So accordingly, we chose the depth of the laying of the mat at 0.5 meter, and ground resistance, finally we got 0.02605 ohm using this design. Grid potential rise was within the maximum limit, and the touch voltage and step voltage, they were also within the limit. Approximate length of the earth grid conductor was found to be more than 17,000 mm, 17,000 meter. So for this whole substation. So it looks like this. You can see that at the peripheries portions, the density is higher of laying the rods. And for all the equipments, we take this connection through the flexible conductors, flexible strips to this rod. At least 2 connections to this ArtMat from each of the marshalling kiosk and boxes. They are connected here for safety of the personnel, operative personnel. One more thing we use is that the isolated interlock scheme, that is also related to safety of the grid. So we have, as we know that we have the double main bus here. So bus 1 and bus 2, all the isolated, we cannot close together. So there has to have some circuit to control all these things. That arc switch is disconnected before closing the isolator, or the isolator is closed before closing the breaker. All these things we are taking care of by having interlock circuits. So role of civil engineers is very important in designing a substation. After finalizing the bay width, like 220 kV, we keep 16 meter from one bay, center line of one bay to the center line of the next bay. It is 16 meter normally. And for 132 kV, it is 12.5 meter. And for 33 kV, it is 6 meter. So preparing all these layouts, electrical layouts, it is followed by the foundation layout, which is prepared by electrical engineers, but ultimately foundations will be designed by the civil engineer. For that, the bearing capacity of the soil, we have already tested before. And now, after having the foundations, we have to put up the structures, and on the structures are mounted the equipment. The control room building shall be suitably located to have a clear view of the entire switchyard. Size of the building should be sufficient to house all the control, protection and monitoring and automation systems and their auxiliaries. The control room should be properly cooled because all the microprocessor based equipments are housed in the control room. So the cooling system design is a part of the substation as well. So there are many things you can do. Although there are standards, there are guidelines, but you have flexibility of doing things at your own way. In many steps, I also took liberty of making some new design like current transformer. We used to have only 5 ampere city or 1 ampere city. So when we standardize that for 33 kV, we will use only 5 ampere relays, and 132 and 220 kV, we will use 1 ampere relay. But for differential protection, you have to match the what is differential protection of a transformer? It matches the high voltage side current to the low voltage side current. If there is any mismatch, it assumes that there is a fault within the transformer winding, because those CTs are placed very close to the transformer. So only the winding is in question. So for differential protection, the CTs are to be matched. So accordingly, I chose one new CT where, because how a CT is designed, there is a coil wound over a round core. So over the core, it is not essential that I have to have only 5 ampere windings as secondary. I can have both of them together. So deviating from all the standard norms, I talked to the city manufacturer and they said, yes, why not? We can make 5 ampere and 1 ampere in the same city. So for 33 kV system, I used this 5 ampere, 1 ampere common city. So that reduced the number of cities actually, and space also could be managed. It became economic also. So one core I used for differential protection, the other cores for 33 kV overcurrent and for other protections, whatever is required. So there is room for improvement, and you can always go out of the way for some improvement. There is always scope for improvement. In building a substation, there are numerous scope for having your own design. So whenever you do such a big project on your own, you have to face some challenge also sometimes, because in my first substation, where 220 kV Ramgarh substation, when I was making, so when the power transformer reached the site, while dragging to the foundation point, it got overturned and it got damaged in the process, and then it was sent again to the factory and back to the, then after repair only it could be installed and commissioned. So there will be such exigencies which you have to face. Sometimes there is some mistake in the wiring, like city neutral, it is the direction of relay gets reversed. Those things are to be set right by trial and error method. So I think I have covered the most pertinent points about design of a substation. I am not going into the technical details because today I am not so much prepared. So I think I will conclude here itself. Thank you so much for your patience.
Thank you very much, madam, for sharing your experiences with us. And we are also delighted to know different practical aspects of this grid substations from you. So we are very much thankful to you, where you have enlightened us with the different practical aspects of these grids. So thank you again. Thank you very much, madam. Now I would like to request our respected HOD madam to give some concluding remarks.
I again come to the dais. First of all, I should extend my deepest gratitude to Mrs. Dattanag for giving such detailed information regarding the substation. And then I will come for one more purpose. That day, Secretary GAABESU, who is here, he just expressed one of our great problem related to the electrical engineering department, that department wise we don't have any database, so that the current students may be connected with the alumni. So it's a huge problem we feel who are in the level of executing such a program. So it's my earnest appeal to my students as well as to the alumni who are present over here. Immediately after this program, tomorrow or day after tomorrow, I shall prepare a Google form. I'll share that with the alumni office bearers so that it will be circulated to the global alumni base. And simultaneously, I shall circulate such a form to my current students so that they will also give their whereabouts details, and just pass out batches also I'll communicate, so that jointly we can develop a good database. And we all can appreciate that in this era of connectivity, we don't have such type of database is not a very healthy sign. So with this, I shall conclude this session. And now it is the time to share the vote of thanks. I shall again request Roshni Madam to come and conclude the session.
Thank you, madam. So now we have came to the end of this program, and from this program we have already know different aspects of this power grids, and in this series of lectures we will also came across different subjects. So we will learn about different things. So now today we have with us Mr. Bishwajit Sengupta, 1981 pass out from Electrical Engineering Department. 1981 pass out from this electrical engineering department. I would like to request him to give vote of thanks.
Hello. Professor A.M. Ghosh. I see Professor Olav Dash in the gallery. Professor Devashish Dutta, I think he has left. Professor Anindita Sengupta. Srimati Sumita Dattanag, Sri Aurobindo Rai. Alumni, current students, staff of GAABESU. It's my distinct honor and absolute privilege to stand before you today to give the vote of thanks in this first of the series of Legends and Legacies, and that too for none other than Dr. Shankar Sen, my professor, a visionary, a father figure, and the kind of affection that he used to give us is absolutely inexplicable. Before I actually give the vote of thanks, I'll just take 2 more minutes. I know all of you have been so patient here. I am so tempted to share with you some interesting anecdotes on Dr. Shankar Sen. Let me first tell you about what others thought about him. I used to know a person, his name is Mr. Adinath Chatterjee. He used to be a director and I believe chief engineer at CESC, Calcutta Electric Supply. I used to know him, and he made a comment on Dr. Shankar Sen. All of us who are electrical engineering students here know that electricity and magnetism go hand in hand. Mr. Adinath Chatterjee made a comment on Dr. Shankar Sen, and the comment was, Dr. Sen, oh, you are a student of Dr. Sen? I said, yes. Wonderful. He can see magnetic flux. Can you imagine what that comment was? He can see magnetic flux. Anyways, another thing that I would like to talk about him. He was a great administrator. I think he was the first one to introduce rotating headship in this institution. If I'm not wrong, he's the first one. It's difficult to leave your position of power, and he was one who just gave it up, let others run the department as well. There used to be a society called Photographic Society during my time, and I'm told it's still there. At that time, it was with films, not digital cameras or anything. Digital cameras were something that we couldn't think of. So as I used to be, I happened to be general secretary of that Photographic Society. And we had arranged a photographic exhibition in Kolkata, invited all the professors. Dr. Shankar Sen was the first one to go. He applauded us for our efforts. The next day, someone came to me and said, Dr. Shankar Sen is calling you. And I was actually surprised because what did I do wrong? Kind of. So I went to him, to his office, and he said, you guys do a great job. How do you get the chemicals for your, do you develop the films yourselves? I said, yes, we print it and do everything ourselves. So he said, how do you get the chemicals? I said, we go to Kolkata and buy it from shops. Who pays the money? I said, we pay the money. He said, do one thing, we get a grant. There is a lab in our department for which we get a grant. That lab, we are getting that grant every year, but then that lab is not functional. So bring back the receipt. You buy the stuff, bring back the receipt. I will make sure that you get money re-grant. What a gesture. That's second point. Third, just the last anecdote that I want to talk to you about. Dr. Shankar Sen and Mashima, I used to call her Mashima, Mrs. Sen, and most of us called her Mashima. They happened to come and join us in a picnic. in New Jersey. And we requested Mrs. Sen to say few words. And she was very shy, she wouldn't speak. And then we said, well, talk about Dr. Sen. So she stood up, and at that time, Dr. Sen was the Power Minister of West Bengal. She said, what am I going to talk about your professor? He is now the minister, and one day it was pouring heavy. He was standing at the window and watching outside the rain. So Mashima asked him, what are you looking at? The rain for such a long time. And Dr. Sen's comment was, those who understand Bengali, I will first say this in Bengali because it has to be like you will only understand it well in Bangla, and then I'll translate it in English. But you will get the essence better in Bengali. He looked outside, it was torrential rain, and Dr. Sen's comment was, "Koylagulo shob bhije gelo." He was the power minister at that time, and it's thermal power station. The coal was all kept outside, and it all got drenched. So that was Dr. Sen. Anyways, as I said, it's a privilege to be a part of a student, to be a student of this stalwart person. And it's always great to come back to this institution where we spent 5 years of our life. We didn't fail. It was 5 years, the last batch of 5 years. So we didn't fail. I wish to thank each one of you. I have named Professor Ghosh, Professor Dash, Ms. Dr. Nag, Aurobindo Da, Professor Dotto, and then the staff of the GAABESU. Thank you so very much for attending it. It's very encouraging to see a full house here. As GAABESU, we would like to conduct such gatherings in the future as well. And so I really appreciate, we all appreciate your presence here, taking time to come over here. And please do continue to support this, this endeavor on our part. Before I conclude, no meeting is complete without eating. So there is some arrangement of eating here. Before you leave, please take a packet. Oh, there is tea also, so drinking as well. Thank you. কোনটা ওই যে ওখানে ইয়ে করছে লিঙ্কগুলো দেওয়া ছিল লিঙ্কগুলো কেন আসছিল না মুশকিল হয় সব লিঙ্ক করা ছিল আমার ফাইনাল কোনোটাই আসছে ক্যামেরা চলছে ক্যামেরা ও ওই ক্যামেরাটা এখানে রেকর্ডিং বন্ধ হয়ে গেছে হ্যাঁ রেকর্ডিং তো বন্ধ হয়ে গেছে হ্যাঁ রেকর্ডিং বন্ধ
বন্ধ করছি রে